Let's go over Pythagorean triples. We know that Pythagorean theorem is a squared plus b squared equals c squared, where a and b are the legs and c is the hypotenuse. So with this, sometimes we do Pythagorean theorem and we're searching for one of the sides, we might end up with a decimal answer. So only select integers work in here. Like we know 3 squared plus 4 squared equals 5 squared. Okay, but if we have a different number, like if this was 3 and this was 7, we'll get a different c. So if we had a squared plus b squared equals c squared, we had 3 squared plus 7 squared, and we solve for c, we get 9 plus 49 equals c squared. 9 plus 49 is 58. When we do the square root of 58, we get 7.61, and it keeps going on. So we don't get an integer answer. We only get an integer when we end up doing the square root of a perfect square. So like the square root of 49, square root of 64, square root of 144. All of those would give us an integer. So a Pythagorean triple is a group of integers that work in this perfectly. So if we want to list some of them, so a, b, the two legs, and hypotenuse, one of them that would work would be 3, 4, 5. That's Pythagorean triple. Another common one is 5, 12, 13. So the legs are 5 and 12, and the hypotenuse is 13. Another not so common one is 8, 15, and 17. These are three Pythagorean triples. 3, 4, 5 is the most common. 5, 12, 13 comes up, and there's also 8, 15, 17. Okay, but these aren't the only Pythagorean triples. There are a lot more. And we actually list some of them based on these triples. So we can just multiply these by any integer, and we'll get a new triple. So for example, if we took 3, 4, 5, multiplied it by 2, we get 6, 8, 10. So that's also a triple, 6, 8, 10. Multiply it by 3, and we'll get 9, 12, 15. Same thing for 5, 12, 13. We could double this. We'll get 10, 24, 26. Multiply it by 3, 15, 36, 39. Another triple. And then we could double this one. We'll get 16, 30, 34. We could triple it. We'll have 24, 45, 51. So these are the more common ones that we're going to see. And the reason why we need to know these is it could save us some time. Rather than do Pythagorean theorem, if we knew that this side was 6 and this side was 10, well, this is just a 3, 4, 5 triangle multiplied by 2. So this is 2 times 3. This is 2 times 5. So this one would be 2 times 4. So we have 3, 4, 5. 3 is multiplied by 2. This side would be 8. So sometimes knowing these triples could save us from doing Pythagorean theorem. But of course, if we knew that this side was 6 and this side was 10, we could find this side 8 just by doing Pythagorean theorem as well.